Hello, everyone. As I said, we are going to have a second session on graphing uh, rational functions. So I said we are going to cover the other uh, cases. So example 2, remember last time we had an example where uh, the degree of the denominator was higher than that of the numerator. And that means that the x-axis or f of x equals 0 was an axis of symmetry. Today we are going to look at the other two cases. So let's take a case where the degree is the same up and down. So for example, maybe we can say f of x equals x squared plus 3x plus 2. That would make that easy one to do. And then let's change that into negative 2x minus 3. Yeah, so so like we said before, we can start first by factoring both the numerator and the denominator to the best we can. So you can see that the numerator here, because you need two numbers that when you multiply, you get 2, and when you add, you get 3. There is nothing more than 1 and 2. So x plus 2 times x plus 1. Now, if I go to the denominator, I see that you need two numbers that multiply to negative 3, which is like negative 3 and positive 1, and they add up to negative 2. So it has to be x minus 3 times x plus 1. Again, I made it so we get a whole. You don't have to do that, but I just want to show you different cases where you get a whole. So the first thing we say is that was number 3 there, if you remember in the 5 parts that I mentioned. So there's a whole at x equals negative 1. That's what makes the numerator, both the numerator and the denominator equal 0. And if x is negative 1, you hide that and you say an f of x is negative 1 plus 2 over negative 1 minus 3. So it's negative 1 over 4, right? Negative 4. So negative 0.25. So the point negative 1 and negative 0.25 is a whole. After that, remember we said horizontal or slant asymptote. Here we know it's horizontal. Why? Because the degree is the same. And of course, the leading coefficient here is a hidden 1, as well as down, it's a hidden 1. So I divide 1 by 1, I get f of x equals 1 is the horizontal asymptote. If you want to see where is the vertical asymptote, you say what makes the denominator equal 0? Remember, negative 1 is already a whole, so we delete it. What makes the denominator 0 is that x equals 3. So the vertical asymptote is that x equals 3. Now, like we did last time, let's prepare that. So I draw my x and y axes. Here is my x-axis. And here's my y-axis, or f of x-axis, since we said f of x, not y. We said we have the horizontal asymptote is at f of x equals 1. So let's do 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, 1, 2, 3, 4, 5, whatever, negative 1, negative 2, so that I see the numbers. I don't do like last time. Oops. First of all, we have a whole at negative 1 and negative a quarter. So there is a hole here. Okay, or I'll make a very small circle here to represent the hole. We have the horizontal axis is f of x equals 1. So here I have an horizontal asymptote. I said horizontal axis. Okay. And then x equals 3 is a vertical asymptote. Again, that divides my area into 4 regions. I know that one of them definitely would look like that since I have a hole here. So I already know most likely there would be these two regions, but we are not going to jump to conclusions. Next, we can find the x and the y-intercept. So how do we find the x-intercepts again? X-intercept, meaning where the graph crosses the x-axis, and at the x-axis, there is no y or no f of x equals 0. So what makes f of x equals 0 is x equals -2. So x-intercept is -2 and 0, that point. So now it's more telling me more than that my branch here would look something like that. What about the y? The y-intercept. Y-intercept make the y. I'm sorry, we did the x-intercept. Y-intercept substitute x equals 0. Again, don't worry about that. If x equals 0, then f of x would be -2/3. Okay, f of x equals -2/3, meaning I have a 0 and -2/3. 0 and -2/3 would be somewhere here. So you can see that here is the branch. We can see that clearly. If you want, we can substitute with an easy number and see, for example, if x is 2. If x is 2, the numerator is 4 and the denominator is -1, so I get to -4. Oops, I made -5 incorrect. It's really not that important. Just -5 is here. Okay, so you can see now I don't need anything else. If I may have an easy number, maybe if I make that -3. So -3 plus 2 is -1, and -3 minus 3 is -6, so it's 1/6. This is 1/2, so somewhere in here. And you can see now that I can draw it something like that. And this one will go very close to x equals 1. And I ended up with this branch. I don't need, it was easy because again, the y-intercept, the x-intercept, and the whole, all of them were in a particular place. After that, we start seeing, or we start asking ourselves, what if x is slightly more than 3? So to see if I'm going to have something that looks like that or something that looks like that. So let's say at x equals 3 plus, meaning slightly to the, I know that slightly to the left, it goes to -infinity. I already have that, so there is no reason to check that. But if I say 3 plus, if this is 3 plus, then that's positive. Notice 3 plus meaning slightly more than 3. So the numerator is slightly more than 5. The denominator is slightly more than 3. When you subtract 3, you get a very small value. When you divide by a very small value, you get a huge number, and it's positive. So I'm heading towards the positive infinity. It's going up like that, and it's going down like that. Again, I don't know how to plot it like in a precise or accurate manner. So I'm going to pick few points, and probably I need something that makes the calculation easy. So if I say 4, for example, if I make x equals 4, the numerator is 6, the denominator is 1, so I get to 4 and 6. If I make that maybe 6, well, 6, maybe 9. If I 7. If I make x equals 7, which is here, then the numerator would be 9 and the denominator would be 4. So 2 1/4 here. Maybe if I try 6 or 5, 6 would make that 3 and that, I'm sorry, 8 and 3, so 2 2/3. 5 would make that 7/2, 3 1/2. And I think that pretty much is telling you, well, this would go up to infinity. So first of all, this goes something like that. And this will go up, passing through that point, and probably would approach infinity when outside the paper. But that would be the general shape of our function like we did last time. Let's redo it here. So the plot would be x squared plus 3x plus 2 divided by x squared minus 2x minus 3. The window, I need to go something to the left of -4, so that's fine. To the right, maybe it would make that 10 or 8 or something. For the y, I can go below, yeah, negative. And above it, yeah, -6, and maybe we can make that 6 also, or 8, doesn't matter. So you can see that this branch goes down, and this branch also is coming like that. If you want to look at the table, what about 4, 4 and 6? How about 2, 2 and -4? Yes, 2 and -4. We didn't try that. The intercept 0 and 2/3, 0, 0 and -2/3, which is this point. -2 and 0, which is that point. -3 and 1/6, which we remember. And then we need to see -1, because that's where we had the error or the hole. There is nothing here. So remember, we made a hole here. And -1 is error, we said. But then how about x equals 3? Error. Why? Because that's an asymptote. You cannot have an x equals, it's either slightly to the right, which goes to infinity, or slightly to the left, that goes to negative infinity, and so on and so forth. So I hope this one was pretty straightforward. Let's take one last example to illustrate the case when we have a slant asymptote. So example 3. Let's pick, say, a square function on the numerator and a linear in the denominator. So if I say x squared minus 5x minus 5, so what can we do? 6, can make it 3 and 2, for example. I don't want to make holes. Oh, okay, so wouldn't, no, if I make, yeah, let's make it 6. And make the denominator x plus 3. Now, I can factor the numerator, but not the denominator. The numerator would be x minus 3 times x minus 2 over x plus 3. I don't have any holes, okay? So now we need to see, since the degree of the numerator is greater than that of the denominator, I have to do long division. So let's do that. Let's say x squared minus 5x plus 6 divided by x plus 3. As I said, when I first saw that, I was in a French school, so the way we do the division is completely different, and I couldn't understand. Even though our friends who went to Arabic school, they use something similar to that, but I never bothered to learn how it's done. So I didn't understand what do you mean by that? It's like it didn't make any sense to me. Anyway, so if I have any of my friends from school watching that, they would laugh, I know. So I divide x squared by x, I get x. So x times x is x squared, x times 3 is plus 3x. I'm going to subtract this. So these cancel. I get negative 5 minus 3 is negative 8x plus 6. And then I divide negative 8x by x. I get negative 8, which gives me negative 8x minus 24. I don't care about the remainder. The remainder here, as you can see, is positive 30 over x minus 8. I don't care about that. I only care about x minus 8. So a slant asymptote is f of x equals x minus 8. That's a straight line with a slope of 1 with a y-intercept of negative 8. So that's what we found. Second, we find the vertical asymptote, what makes the denominator equal 0, which is x is negative 3. So x equals negative 3. I don't have holes, so there is no number 3. No holes. Number 4, we do the x-intercept, set f of x equals 0, meaning the numerator equals 0, so I have x equals 2 and x equals 3. That's what make the numerator equal 0. And finally, the y-intercept, set x equals 0, so you get 6 over 3, right? If x is 0, these three terms would be 0. And you get 6 over 3, so f of x equals 2. So let's do that. I don't have a horizontal asymptote. I have a slant asymptote, which two of them. Like before, I'm going to draw my x, y, and the asymptotes first. And no holes, we said. F of x. Let's take the points that we know. So first, we have the x-intercept is at, I have an x-intercept here and an x-intercept there. I have the y-intercept here. We don't know how far we need to go, so we'll see. So these are the 3 points that we know. Slanted asymptote. Notice that I have a y-intercept at negative 8, right? Negative 7, negative 8. So I have a point here, and I have a point at 8 and 0. So the slant asymptote goes through these 2 points. The vertical asymptote is at x equals negative 3. So I think I didn't draw it in a good manner. I have to shift it up. I should have checked that. I'm sorry. So let's do this quickly so you can see it. So this time I'm going to go high here for the x-axis and maybe slightly to the right for the f of x or y-axis. And maybe I'll go by 1 instead of by 2 in numbering them. So I can say 1, 2, 3, 4, 5, 6, 7, 8. There is a point here. Negative 2, negative 4, negative 6, negative 8. So that would be a better. So I don't want to show that one branch is outside of the paper. It doesn't make sense, right? -1, -2, -3. That's the vertical asymptote. Maybe I should have picked the numbers better. Just wanted to make sure we don't have holes since we covered two cases with holes. So the numbers I picked maybe are not the best. Okay. So as we said, it's passing through 2 and 3 and 0 and 2. That's the y. No, I'm sorry, 0 and 2. How do I cross that? 0 and 2 here. So 0 and 2, this is the y-intercept. 2 and 0, 3 and 0, I don't think we have. So I know that this piece is going like that, right? It's very easy. Uh, if we make, say, x equals 6 or 4, 4 would give me 1 times 2 is 2 over 7. So it's slightly positive. Okay. Um, let's say at 6, 3 times 4 is 12 over 9 is 1.33. Okay, so I can see that this guy is coming from up here at infinity, crossing the x-axis, but then going up again and doing this. Of course, this is curved a little bit, but it crosses at 2 and 3, meaning it goes below the x-axis and then above again. And you can see that if I substitute numbers here, like 6, I get positive, not negative. So it's not going like that. No, it's crossing and doing something like that. Okay, how about if x is 3 negative, meaning to the left of -3, is it like, is it going something like that or something like that? So at -3 minus, -3 minus 3 is negative, so the numerator is negative, and -3 minus 2 times negative divided by -3 negative, meaning less than -3, like -4, for example, plus 3 is also negative, which means the numerator is positive, negative times negative is positive, and the denominator is negative, so positive over negative is negative, meaning I'm going down here. So it's going to look something. Oh, I'm sorry, it's going down here. So I'm going something like that. And again, I can make it more accurate or more precise by taking points and see how close it gets to the line. So to the negative of to the left of -3, it's going down to -infinity. To the right of -3 is going up to positive infinity. And of course, this is not drawn properly, but it looks something like that. Let's enter that in. Oh, now let's clear this and say the numerator is x squared minus 5x plus 6 divided by x plus 3. Let's look at the window. The window has to go, let's make it -10 or something, because this is -3, so -10, and then +10 also is good. For the y, I have to go really down. So I say negative, say 15. Let's try. And positive 5. Let's see. Oops. No, that's very bad. But you see, it crosses at 2 and 3 and then goes slanted. On this side, it's very down. Oh, that doesn't make sense. I had, yeah, it has to go be much below that. So let's change. But I said negative 15, negative 10, oh, 14. So maybe negative 25 and see if that would show it. I'm doing something wrong. Why it's not showing here? That doesn't make sense. Let me see the equation. I wrote x squared minus 5x plus 6 over x plus 3. How about the table? Negative 3 is error, we know. At negative 2, it's 20. It's very high. And then negative 1, it's 6. At 0, it's 2. We know that. At 1 is 0.5. And then at 2 and 3, it's 0. So far, so good. Okay, how about the negative side? Negative 3, it's error, we know. How about negative 4? It's negative 42. Oh, you see, that's why I said try to take points to the left to draw it properly. Again, even though I moved the x-axis very high, I still didn't treat this. So you can do something like that. You can say, because otherwise the negative 40 is outside of the paper. So we know that at negative 4, when I go to negative 4, it's negative 42. So you can say, for example, this is negative 38 or negative 30 and negative 40, negative 42, negative 44, and so on and so forth. So that's why it didn't show up in the graph. So we needed to change the window and make the y-intercept maybe negative 60. And let's see if that, yeah, now that shows that. That's this part. And then the other part is there. Again, so you can see that, again, it wasn't a good choice of numbers. I apologize for that. But I think you can see how easy now, if you do systematically, you can find a hole if there is one. You can see whether it's horizontal or slanted asymptotes. You can find easily the the vertical asymptote, the x-intercept, the y-intercept. And as I said, it's always a good choice to pick numbers and to find how high or how low each branch is. Like in this case, we had to go down to negative 42 just to show this. I didn't expect it because I didn't do the math, and it's my mistake. But I hope this was clear for you. And as I always say, if you have any comments, please write them down. I'll get back to you as soon as I can, or maybe show another video to elaborate on that. I think I'm going to move to a different topic unless you have any questions further, or you need further examples on um, uh, graphing function or rational functions. Thanks very much for your time, and I hope to see you soon. Thanks. Bye.